Welcome to the fascinating world of lakes, where physical, chemical, and biological factors come together to create vibrant ecosystems. These seemingly tranquil bodies of water are teeming with life, from the smallest microscopic organisms to the largest fish. Today, we'll embark on a journey to uncover the intricate workings of these aquatic worlds, exploring the delicate balance of life that exists beneath the surface. Join me as we delve into the key elements that affect aquatic life in lakes, from the sunlight that filters through the water's surface to the nutrients that fuel the growth of underwater forests. We'll uncover the secrets of these hidden ecosystems and understand why studying these bodies of water is crucial for the health of our planet. Just as the Earth's diverse landscapes shape the life they support, the physical attributes of a lake profoundly influence its inhabitants. The clarity of the water, the temperature of its depths, and the very shape of the lake basin all play a crucial role in determining the delicate balance of life within. Imagine a lake fed by a rushing mountain stream, its waters cool and clear, cascading over rocky beds. This vibrant environment will be home to creatures adapted to thrive in fast-flowing, oxygen-rich waters. Contrast this with a shallow, sun-drenched pond, its surface shimmering with the verdant growth of water lilies. Here, a different cast of characters emerges, adapted to warmer temperatures and the shelter provided by abundant vegetation. Temperature acts as an invisible hand, shaping the lives of lake inhabitants in profound ways. As the sun's warmth bathes the lake's surface, a gradient of temperatures emerges from the warmer, oxygen-rich upper layers to the cooler depths. This thermal stratification, as it is known, dictates where organisms can survive and thrive. Picture a school of fish, their movements synchronized as they navigate the warm, sunlit waters near the surface. Here, oxygen is plentiful and food is abundant. Yet, as we descend deeper into the lake, a different world emerges. The water grows colder and oxygen levels dwindle, creating a challenging environment for many species. Only those adapted to these conditions can survive in this twilight realm. Light, the lifeblood of our planet, plays a pivotal role in the intricate ballet of life within a lake. As sunlight pierces the water's surface, it sets in motion a chain of events that sustains the entire ecosystem. It is within this sun-kissed zone that microscopic algae, the very foundation of the aquatic food web, harness the sun's energy to create food, releasing oxygen in the process. Observe how the intensity of light changes as we descend deeper into the lake. The once bright rays gradually fade, transforming the underwater landscape into a world of muted hues. Here, in the depths where sunlight struggles to reach, a different type of life persists. Shade-tolerant plants and algae have adapted to thrive in this low-light environment, their presence a testament to life's remarkable ability to adapt and flourish. Chapter 4. Water in motion, a constant dance of renewal. Unlike the stillness we often associate with lakes, the water within them is in perpetual motion, driven by a combination of natural forces. Wind, the unseen hand of nature, whips across the surface, creating ripples that transform into waves. Their rhythmic dance a testament to the lake's dynamic nature. These movements are not merely superficial, they play a vital role in maintaining the lake's delicate balance. Consider the flow of rivers and streams that feed into the lake, carrying with them vital nutrients and oxygen. These inflows, along with the lake's own internal currents, ensure that the water remains oxygenated and that nutrients are distributed throughout the ecosystem. It is this constant circulation that prevents stagnation and supports the diverse life that calls the lake home. Chapter 5. Size and depth, shaping the lake's character. The size and depth of a lake are not merely static measurements, they are fundamental factors that sculpt the very character of these aquatic worlds. A vast deep lake, its depths plunging far below the surface, presents a very different environment compared to its shallower counterpart. In the profound depths of a large lake, distinct layers emerge, each with its own unique set of physical and chemical characteristics. Contrast this with a shallow lake, where the sun's warmth penetrates the water column with ease, creating a more uniform environment. These shallower waters, while lacking the dramatic depth gradients of their larger counterparts, often teem with life, their sunlit depths supporting a vibrant tapestry of plants, invertebrates, and fish. Chapter 6. The Invisible Hand, Unveiling the Chemical World. While the physical attributes of a lake, its size, depth, and movement are readily apparent, it is the unseen chemical world that truly governs the delicate balance of life within. Just as our own bodies rely on a complex interplay of chemicals, so too do the inhabitants of these aquatic ecosystems. The chemical composition of a lake's water, often invisible to the naked eye, dictates which species can thrive and which struggle to survive. The presence or absence of essential nutrients, the pH level, a measure of acidity or alkalinity, and the dissolved oxygen content all play a crucial role in shaping the lake's character. Oxygen, the breath of aquatic life. In the underwater world, just as on land, oxygen is synonymous with life. Fish, invertebrates, and even the microscopic organisms that form the base of the food web all rely on this vital element to survive. Dissolved oxygen, the lifeblood of aquatic ecosystems, enters the water through a combination of diffusion from the atmosphere and the photosynthetic activity of aquatic plants and algae. Imagine a clear, fast-flowing stream, its waters tumbling over rocks, each splash replenishing the water with oxygen. Contrast this with the depths of a stagnant pond, its surface choked with algae where oxygen levels plummet, creating a perilous environment for fish and other aquatic life. These contrasting scenarios highlight the critical importance of maintaining healthy oxygen levels within our lakes and rivers. The delicate balance navigating the pH spectrum. The pH level of a lake, a measure of its acidity or alkalinity, acts as an invisible conductor, influencing a multitude of chemical and biological processes within the aquatic ecosystem. Just as the wrong pH balance in our own bodies can disrupt our health, so too can extreme pH levels in lakes have devastating consequences for aquatic life. Imagine a pristine mountain lake, its waters crystal clear, fed by snowmelt and rainfall. The pH of this lake will be naturally slightly acidic due to the decomposition of organic matter. Contrast this with a lake situated in an area with limestone bedrock. The dissolved minerals in the water will buffer the pH, creating a more alkaline environment. Each type of lake, whether acidic or alkaline, supports a unique community of organisms, adapted to its specific conditions. Nutrients, feast or famine in the aquatic world. Nutrients, the building blocks of life, play a critical role in the health and productivity of our lakes and rivers. Nitrogen and phosphorus, two of the most essential nutrients, fuel the growth of microscopic algae, forming the foundation of the aquatic food web. A delicate balance exists, however, between the right amount of nutrients and an excess that can tip the scales from vibrant life to ecological disaster. Imagine a lake where nutrient levels are naturally low. While this might seem like a disadvantage, it actually fosters a unique ecosystem characterized by clear waters and a diverse community of species adapted to these nutrient-poor conditions. Contrast this with a lake that receives an overload of nutrients, often from agricultural runoff or sewage discharge. The result is a phenomenon known as eutrophication, where excessive nutrient levels trigger explosive algae growth, choking the waterways and depleting oxygen levels. Chapter 10. Pollution, a shadow over our waters. Pollution, a pervasive threat to our planet's health, casts a long shadow over our lakes and rivers, disrupting the delicate balance of life within these precious ecosystems. From the bustling cities to the rural countryside, human activities often leave an indelible mark on the waterways that sustain us. Industrial discharges, agricultural runoff, laden with pesticides and fertilizers, and even the seemingly innocuous act of littering all contribute to a cocktail of pollutants that can have devastating consequences for aquatic life. Heavy metals, persistent organic pollutants, and plastic waste accumulate in the food chain, poisoning wildlife and threatening human health. Chapter 11. Biological interactions, the web of life unfolds. Beneath the tranquil surface of a lake, a complex tapestry of life unfolds. A delicate dance of predator and prey, competition and cooperation. This intricate web of biological interactions shaped over millennia is essential for maintaining the health and stability of these aquatic ecosystems. From the smallest microorganisms to the largest fish, every organism plays a role in the grand scheme of life. Imagine a school of minnows, their silvery scales flashing as they dart through the water, feeding on microscopic algae. These minnows, in turn, become a meal for larger fish such as bass or trout, perpetuating the flow of energy through the food web. The death of these top predators, while seemingly marking the end of a life cycle, actually fuels new life, as their decomposing bodies release nutrients back into the ecosystem, nourishing a new generation of organisms. Chapter 12. Plants and Algae. The architects of the underwater world. Plants and algae, the primary producers of aquatic ecosystems, form the very foundation of the food web, harnessing the sun's energy to create food and oxygen. These underwater architects, ranging from microscopic phytoplankton to towering weeds, transform the physical environment of the lake, providing shelter, food, and breeding grounds for a myriad of creatures. Picture a bed of submerged aquatic plants, their slender stems swaying gently in the current. These plants, often referred to as the lungs of the lake, release oxygen into the water, vital for the survival of fish and other aquatic organisms. Meanwhile, on the surface, floating algae blooms, fueled by sunlight and nutrients, create a vibrant green tapestry teeming with microscopic life. Fish, the most charismatic inhabitants of our lakes and rivers, capture our imaginations with their beauty, agility, and often elusive nature. From the darting movements of tiny minnows to the powerful leaps of predatory pike, these aquatic vertebrates occupy a crucial position in the food web, both as predators and prey, but the animal kingdom within a lake extends far beyond fish. Turtles, their ancient shells gliding through the water, bask on logs, soaking up the sun's warmth. Frogs and toads, their calls echoing across the water at dusk, lay their eggs among the reeds, their tadpoles adding to the teeming life of the shallows. And high above, ospreys circle, their keen eyes scanning the water for a glimpse of a fish, their successful dives a testament to nature's precision and power. While we often focus on the larger, more visible inhabitants of lakes, it is the unseen world of bacteria and decomposers that truly underpins the health and stability of these ecosystems. These microscopic heroes, working tirelessly in the shadows, perform a vital service, breaking down dead plants and animals, releasing nutrients back into the water, and completing the circle of life. Imagine a fallen log slowly decaying beneath the water's surface. To our eyes, it might seem like a scene of decay, but to a teeming community of bacteria and fungi, it is a feast. These decomposers, breaking down the complex organic matter of the log, release nutrients back into the water, making them available to fuel the growth of new life. The delicate balance of a lake ecosystem honed over millennia can be disrupted by the arrival of invasive species, often introduced through human activities. These newcomers, lacking natural predators or competitors, can outcompete native species, disrupt food webs, and even alter the physical characteristics of the lake itself. Imagine a lake once teeming with native aquatic plants, now choked by the dense mats of an invasive water hyacinth, its rapid growth blocking sunlight and depleting oxygen. Or consider the introduction of zebra mussels, their tiny shells encrusting every available surface, outcompeting native mussels for food and habitat. These are just two examples of how invasive species can wreak havoc on lake ecosystems, highlighting the importance of preventing their introduction and controlling their spread. As we've journeyed through the intricate workings of lake ecosystems, we've witnessed the delicate balance of these aquatic worlds. Studying lakes is essential for keeping our water clean, protecting wildlife, and managing resources like fish. The knowledge we gain from understanding these complex ecosystems inform decisions about how we manage and protect them. By understanding these ecosystems, we can ensure they remain healthy and vibrant for future generations. It is our collective responsibility impact our actions have on these precious resources and to advocate for their protection. From reducing pollution to preventing the spread of invasive species, every action, no matter how small, contributes to the preservation of these. Thank you for joining us on this journey through the ecology of lakes. Until next time, keep exploring and protecting our natural world. Let us ensure that the ecological integrity of these aquatic wonders endure for generations to come.